Good afternoon. I hope everything is going back to normal slowly but surely. And we will start doing our presentation for this afternoon. It is now 3:30 afternoon in Israel. And first of all, I would like to apologize the small technical issue for the delay of starting, but here we are and we will start. Our presentation today will talk about the soft way to fit keratoconus and irregular corneas. Common lens application for irregular corneas. It is keratoconus, post-graft, pellucid marginal degeneration, the PMD, corneal scarring, ectasia, post-refractive surgery, RK, PRK, post-LASIK, and oblate corneas, post-trauma / corneal SARS, corneal dystrophies. The most important tool that we can use in order to evaluate the irregularity of the cornea is the corneal topographer. Working with the corneal topographer is a non-invasive medical imaging technique for color mapping the surface curvature of the cornea. Recently, this instrument has become an important and necessary instrument in clinics for checking the eye cornea. And we have some options with this machine that are giving us an option in order to evaluate the tear layer, the quantity and quality of the tear layer, evaluate the sag of the cornea, evaluate the power of the cornea, means that we can do with these measurements, we can do we can have a lot of parameters in order to evaluate the best fitting for this irregularity cornea. Here we can see some cases of keratoconus or ectasia of the cornea. In the left, it is just the beginning or even without. This is a way of keratoconus, oval conus, and by the end we find out that there are some tears in the corneal layers, and this is oval cone or even worse. This is a sketch, nice sketch, just can give us an idea what is a nipple cone, oval cone, and global cone. You see that it is related to surface on the cornea, but what most important is that if we are checking a person and I just have a case today, and we are looking at a global conus, the power of the cornea can be very nice. The vision can be very nice with spectacles, but the field of the view is very, very small and very, very thin. So we have to do a topography, because in this case we will find the case, the K reading can be 7.9 by 7.8, which was the parameter today. The patient can see very nice with spectacles. His other eye was something like the oval, which has a very bad vision. So he asked me if we are going to semi-scleral lenses in both eyes, and I told him, look, show me please the topography. And when he showed me the topography, immediately he understand that he has to go to the same solution in both eyes. Another type of ectasia, we call it the pellucid marginal degeneration, the PMD, which we call two-bird kissing, if you can see here in this area. What happened is that due to weakness of the lower part of the cornea, we get a shape like a pregnancy in the last week. Okay, so to fit cases like this, it's very terrible. When you go to measure this case or to suspect without a topography, in this case, normally it is plus power on a minus high cylinder, but in 90 degrees. When you have a case like this and the K reading shows the astigmatism, suspect, take the topography, and you will see. What I suggest is always start with a topography, because when you're doing the topography, immediately you have the solution what to fit. Another type of ectasia is a post-LASIK ectasia. This is oblate cornea. It can be also post-implant of new cornea or some PRK operations. So we have, seems like a orthokeratology, but what happened is because they took the doctor, the ophthalmologist, took out some tissues of the center of the cornea, the intraocular pressure press the cornea out, and we get here some ectasia that looks like a keratoconus. What are the main problems caused by the keratoconus or the irregular cornea? At the first stage, there is a vision loss. The cornea gradually thins and becomes B-shaped. The cornea surface becomes irregular, similar to the shape of a cone. This is at the beginning, but in the latest stages, not everyone get it, but there are some people that they get an opaque cornea. It's like taking a nylon bag and stresses, and by the end you see that it becomes white because the effort you do this. In this stage, the only solution is a corneal transplant. But we know that after corneal transplant, many times we need to do contact lenses in order to vault the irregularity of the operation. What are the common treatments for distorted cornea? First of all, our subject is the contact lenses. So we have special design gas permeable lenses like higher sphericity, multi-curves, reverse geometry, high decay hybrid lens, which has soft skirt in the periphery and hard center. Special design hydrogel or silicone hydrogel lenses that we will talk today. Piggyback means that we have a soft contact lens, mainly one day disposable silicone hydrogel lens, carry a gas permeable lens, so you have to replace the soft lens every day. Then we have scleral and semi-scleral GP lenses, and there are some corneal operations like corneal graft, like intacs, like crosslink, but most of the operations stop or delayed the keratoconus, and we have to put a contact lens solution in order to improve vision of for the patient. So what is our main goal? Our main goal is to take a blurry vision and to give good vision. This is at the beginning our goal. The patient cannot see, cannot work, cannot do his daily activities. So when we give him a blurry vision like this and convert it to very nice vision like this, and we know all that we can get this, we did our goal. So beside, of course, the vision, we get excellent vision day and night. It's very important by night because people are driving, no glare, high level of comfort for many hours when the patient is working. Of course, he has to use his lenses as much as he works, or after work he's going to enjoy, to see movie, etc. High oxygen material for corneal health, easy to fit and to adapt, available to all. The prices should be normal and common and very easy to handle. So when we get all these features, we are doing our job. What is a guide for specialty contact lens fitting? First of all, we know we have to have the case history. Everyone has his own history. He didn't get his irregularity from the morning. He get it for few years or few months. So he has an history. We have to analyze to understand what is the situation and what is demand. Evaluate the tear quality and quantity. This is a very important with our decision to go to this type of lens or to the other type of lens. Refraction and free vision quality. We have to have a target, a minimum target to our fitting. Normally, what we are doing a pinhole in order to understand what is the level that we can get from his vision. Selecting, of course, we have to do, we have to do topographies or OCT of the cornea in order to understand the shape of the cornea, the elevation of the cornea. The elevation is very, very important when we are fitting irregular corneas. Selecting the first choice trial set, evaluate the fitting with slit lamp, using fluorescein for GP lenses or big molecule fluorescein for soft lenses. Of course, if we try something and it's not good, we have to change the lens. Then we have to get the final power of the lens and then to order the lens. And after ordering the lens, we have to have a regime for our customers for follow-up. When you get the lenses, how long, how many days after he has to come to us, every 3 months, every half month, and in a year time. We have to follow it, of course, with a cleaning method, care system, etc., etc. Of course, this is something that is involved in the fitting. The soft way to fit keratoconus and irregular. Why soft lenses? Comfortable option to correct their vision problems. GP lens intolerant. Previous soft lens users may be used to disposable lenses, and when we give him GP lenses, he will throw us away. Need frequent replacement with silicone hydrogel. And improve lens stability of on the cornea, because when he has a GP lenses, he lost his lenses every other day. So he needs something that will be stabilized on his cornea, and he can be with the lenses for a year or 3 months, depend the type of the lens, not to replace it every 2 weeks. Since 1970, numbers of contact lens manufacturers have developed soft lenses specially designed for the optical correction of irregularity, astigmatism, resulting from a wide range of corneal conditions, including keratoconus, PMD, etc., etc., etc. But all of them just use the idea of having a normal lens, thicker. Take the lens that you are manufacture, make it thicker, and you will have. But the most problems with those lenses was the oxygen permeability or the tear movement under the lens. One such lens is the soft K lens from us, from Soflex, and the idea is that we change the whole idea of soft lenses for irregular corneas. So all the soft K is a family of lenses, and we will go through it. We have hydrogel and silicone hydrogel lenses. We have the soft K2, which is the most advanced design. It is very similar to the soft K with some added value. We have the silicone hydrogel soft K, and we have the silicone hydrogel semi-scleral soft K, which I will describe it later. All those lenses we can put front and back toric power if needed. Okay, this is the idea that we have normal cornea, we can see very nice, but when we have distorted cornea, we have a very distorted vision, so we have to do something. When we first thought about the idea of doing soft contact lenses for keratoconus, first of all, we have to find a material, a soft material that its modulus is higher. If we are talking about the normal GM3 material or the HEMA material, or the modulus are something between 15 to 20, 22 megapascal. But Contomac has new materials. One of them is the hydrogel 67 water content, 67% water content, which high content of water, but the modulus is higher than the GM3 material, or the definitive, which their modulus is quite similar. So we have two materials that we can start working with them. Then we have to find, to say, we need carrying periphery that will be like every other soft lens. The idea that we have to take a thick lens, we have to reduce the diameter in order to have more oxygen going into the cornea. So we did a very similar edge to the normal lenses. Therefore, we need to have a special lenticular area. And then we need a designer program in order to make this area where it is the pressure balancing holes a strong area, a strongest area. Unfortunately, I'm not, instead of you to demonstrate it, but believe me, for example, if we take a paper and we just make a fold on it, it becomes stronger than just a paper. So this is the idea of the mechanical aid that we have done here in this area. and all the other optic zone is a thicker optic zone in order to cover a high order aberration of the cornea. The most important issue is the pressure balancing holes. At the beginning of the design of the soft K lens, we didn't put these holes, and we found out that the lens is like gluing into the cornea after every blink, and then it takes few seconds to release. So in those few seconds, the vision become blur. And the moment we add the pressure balancing holes, it solves the problem and give us some other advantages, as we will see in the next slides. We also thought about having deposit in this area, but we find a way to do this area here smooth, and of course in the other side. And when we clean this lens daily with a hydrogen peroxide system, we get for a year a very nice and clean hole without any deposit on it. We can see here a nice picture with this lens. The idea is that the holes should be in the limbal area close to the cornea, close to the iris, and it's also depending the size of the cornea. But in most of the cases, when the patient has something in like a 12 millimeter diameter HVID, it is over there. So what those holes give us? First of all, it improves tear flow. We find out, and I used to have a nice picture of this, like these fenestrations holes act like a fountain. It is, of course, improve oxygen permeability because of the tear flow, the high-speed tear flow. Very important is equalize the pressure between the front and the back surface of the lens, stabilized and improved vision, and no air bubbles. What we find out, it is improved the stabilization of the lens, and the lens in 95% of the cases, if it is fit okay, the lens is very, very centering. So these are only because of these fenestrations holes. What are the soft K benefits? There was a research of Dr. Boris Sevrinsky in Hadassah Hospital in Jerusalem that he found out that it improved visual performance, it maximized patients' comfort, and one of the major issues was to improve wearing time. And we find out that 90% of the users wear the lens more than 8 hours. 8 hours, let's say, we call it a day work. But most of them, we can see it here, 56% can wear the lens even more than 12 hours. So we were very, very happy with this figure. Professor Bareket from Tel HaShomer Hospital in Israel also did a nice research of this lens. She was the first to do research with these lenses. And here I get some graphs that she prepared according to vision. So we have the red line, which is the uncorrected visual acuity. This is our reference. And then the yellow line is the vision of these people with their previous vision aid. Either it was spectacles, either it was previous contact lenses. So it is not just glasses or contact lenses, it is their previous to see what is the benefit that they get out of these lenses. So we find out that in most of the cases, there is a huge difference between the average of the yellow line and the average of the green line. In many cases, we got a very nice of 6/6 vision. They did the same research after 1 year on 16 eyes. At the beginning, there were 30 or 40 something like these eyes. After 1 year came only 16 eyes, but we can see that the green line is still very good position, and we are very happy with this solution. We find that the red one is at the beginning, at this, and the green one is at that time, and we find out that in most of the cases, even all of them, in part of them, they are even improving, but in most of the cases at the beginning and after 1 year, they go to the same vision. Another research that did Jose Gonzalez from Minhoj University in Portugal, he took, beside all the other information he get that are quite similar to the previous researchers, he took and find out what happened in contrast sensitivity. And he found out, and he tried to compare it to glasses, to GP lenses, and of course the soft K in red. And he found out that in most of the cases, of course, in the very important area of the cycles, we get a very, very nice vision, even better than GP lenses, and very similar on the high frequency. So, and of course, we find out that the spectacles are going down and down and down. So the information are very, very important for us about the stabilization of the vision with soft lenses, soft spatial lenses for irregular cornea. So the conclusion was that 6 soft contact lenses produce satisfactorily a significant flattening and regularization of the ocular surface. High contrast logMAR visual acuity improved by 2.5 and monocular, and by 3 lines binocular. In low contrast, 2.5 in monocular and 3.5 binocular. Eye order aberration decrease significantly, justifying objectively the improvement of visual function. So if we take this and we put it on this information, we say that one caused the other. So eye order aberration improving the contrast sensitivity. The soft K2. The soft K2 is it's not new design, it's about the same design, but we added more parameters to this lens. We add the material from one point of view, the silicone hydrogel. We add the front toric option, which doesn't affect the stability of the lens, doesn't affect how the lens is sitting in the cornea when you put the back toricity, so it doesn't interfere, but it is improved nicely the vision. And we added another few lenses in the trial set, and we add also the 14.8 because of the most of the lenses are now today silicone hydrogel. So if this was the three normal trial set that we uses before, today we are giving 9 lengths of trial set in 2 diameters. The trial set is manufactured from Contaflex 67 because this is a very stabilized material. If we are doing this from silicone hydrogel, we have to change every 3 months since opening the trial set. Of course, no one wants this, but we find out that fitting with the 67% water content and order the silicone hydrogel, the results are the same. So we have 9 lenses in the trial set, 2 diameter, and we can order 2 options of material with this trial set. It's easy to fit, very easy. We put the lens, we will see in next slides how we start fitting the lenses. The lenses has a spheric front surface in order to control the eye order aberrations. There is a front toric option if we need the refraction to be with toric as well. My suggestion is to leave as much as we can the spheric trial lens, because if we put the lens an hour and a half, we found that the astigmatism needed to the over refraction is smaller than in the beginning. We get high comfort rate, high physiological performance, and it is compatible with the soft K, means that if someone was fitted with the old soft K, we can order him with the same parameters, the soft K2. We are using 2 materials. The one is the definitive 74 of Contomac, which is a silicone hydrogel. It's a non-ionic. The DK is 60, so it has double the oxygen than the hydrogel. 74 water content. The modulus is 0.39 megapascal, lowest dehydration, and 3 months replacement, which is very important that we can change 4 times a year the lenses. The other material is the Contaflex 67, also Contomac, hydrogel, non-ionic. The DK is half of the silicone hydrogel, 67% water content, and the modulus is about the same, 039 and 036, it is about the same. And the same fitting instruction and trial set for both material. This is very important. Talking about fitting these lenses, there are 2 fitting techniques. One is the keratometric formula, and one is the sagittal height formula that we have to have the topographer that give us the elevation of the cornea. But let's find out what we have. So we have 2 lenses. We have base curve in parallel to SAG for 14.2, base curve in parallel to SAG in 14.8. The first step is to decide what is the diameter that we start with. The formula is to take the HVID, horizontal visual iris diameter, and to add 2.5 millimeter, and the bigger than should be the trial set diameter. Another option that we have and is a ruler that show us, you can see it here, how we can measure the HVID, very easy, and we can see the large the normal and the small, but of course the formula is the same, lens diameter bigger than HVID plus 2.5 millimeter. Step 2 is to determine the base curve radius. So what we are doing first, we take the K flat and the K steep. This is the mean, and we take the base curve. It is 6.2, the average plus 1, it is 7.2. So the first choice base curve is approximately 7.2. Of course, the bigger, of course, we are going bigger. So the first closed lens is the 7.3. The SAG method, of course, we have to analyze, and we will see immediately how we getting to this parameter, the SAG of the cornea. If we need 14.2, we are going to 7.3. If we are going to 14.8, the SAG is like this, we are going to 7.6. When we talk about our cornea, we can find that the upper picture is a common and normal cornea, and the lower is a keratoconic cornea. We found out that if we are going from 15 millimeter to 10 millimeter, the amount or the SAG is about the same. We can see here it's about 2000 micron. Okay, no the difference of 22 micron from this eye to this eye. Okay, but if we are going to the next slide and we looked from 10 millimeter to 0, we found out that the normal cornea is 1750 microns, and the ectasian or the keratoconic eyes is 1960 from 10 to apex. So this is a difference of 217 microns. So by the end of today, we can do a calculation. We know that most of the topographers can give us a 10 millimeter elevation from the lower to the higher. This is the elevation. Add to this 2000 micron, and we can have the nice parameter of the SAG. The Medmon topographer, who is familiar with this topographer, allowed us with the composite system to evaluate the shape of the cornea up to up to 15 millimeter. So it is a very helpful instrument to get a full cornea picture and elevation. When we look some machines that used in Pacific University to evaluate for the same patient the SAG at 15 millimeter, we found out that the Medmont was 3,700, the Eagle Eye was 3,680, and the Zeiss OCT was 3,700. So it is about the same measurements for three different machines. So we can rely on these machines to evaluate the SAG of the cornea. So if we are talking about 14.2, we take the SAG height at 15 millimeter and add 500 microns. If we are talking about 14.8, we take also the sagittal heights at 15 millimeter and add to this 1000. Of course, this is only theoretically, this is only to get to the first choice lens. Of course, we put the lens on, put it on eye. We cannot do a fitting without using the trial set, because the final power is very, very important to do it with the triset. It is not a disposable lens. So this is only the first choice. So we get to the power 14.2 will be 7.3 for 14.8. At this SAG we get 7.6, but this is tables that you get them. So let's see some case reports. This is a patient that was intolerant to GP lenses in a university in Pacific University, and they tried, Professor Patrick Caroline tried the soft K on this case. And you can see here the cross section of the lenses on his eyes. Here it's bigger. You can see that the lens is lying on the apex and very, very stable. You see this line is very, very unique. And we can see the tear layer here in between. We will see later a fluorescein picture with these lenses. So he measured and they decide that he's going for a 14.2 millimeter diameter lenses because the HVID was smaller and they need a smaller lenses. Because of the average 7.85, he decided to go on the right eye to 7.90, and here it was exact 7.6 after measuring the K readings. As I told you, this is only a first choice. Maybe in both eyes you should use 7.9 or vice versa. So don't take this as a rule of thumb. Here we can see the nice stabilization of the lens on the right eye and on the left eye. We see it's very, very in the central. So by the end of the day, he ordered these lenses with a small astigmatism, minus 125 at 85, minus 1.5 at 180, and got a very nice vision. This patient was a very low vision at the beginning of the process. The lens, as you see, very are centrate, and they have a very good movement. One of the nice things to do is to use the differential map view. So what we can take it is the topography before the lenses, the topography with the lenses, and to do one difference between another, and we find out that we have a very nice curvature of power that allows us to see that the astigmatism now is very, very small, and it can have a very nice vision with these lenses. Another case was keratoconus, free visus 616. The spectacle power, spectacle lenses power was +1, -6, 140, 615 minus. The K rating is this and this. We use a soft K toric 14.2, 7.6, power -150, -125 at 125 degrees, and the vision was 6.6. We have another case of intact. We can see here the nice topography of the intact, and also with a soft K toric with only -1 diopter at 60 degrees. We get a nice vision of 6.6 minus. This is a full intact, only spheric lens -1. We got a nice vision of 6.6. Troubleshooting. In order to stabilize the toric lens in large diameter, this I can recommend you just, even so the fitting instruction shows you to go to 14.2. When you need a astigmatic prescription, take the 14.8 lens. It will improve stabilization. If air bubble is trapped, you should flatten the lens. In most of the cases, just rubbing a bit the lens will take off the bubble that caused by insertion, but rarely it happens, so just going to a flattened base curve. If there is excessive movement, enlarge the diameter. The toric diagnostic mark assignment at 6 o'clock, 270. Front toric design is recommended for all the soft K family. This is very important, as I explained before, that we don't want to change the shape of the base curve after we fitted the lens. Another lens that it is a huge advantages for your clinic is the HS semi-scleral soft K. The lens was designed with me and with Dr. Boris Sevrinsky for Adasa Hospitals just after they start the cross-linking performance because the cornea was sensitive, and with normal therapeutic lens, the patient did get visual acuity. So we decided let's do a nice therapeutic lens that will have the option of a nice vision and nice curing of the cornea, which is very, very important when we are talking about operations that harms the epithelium layer. When you use a stiff and big therapeutic lens, of course, such a semi-scleral soft K, the curing is very, very, very good without any pains, and the results was fantastic. And you can use these lenses later as a vision aid. Soft scleral lenses, why is it good? It's comfort, centration, and for RGP contraindicated. Silicone hydrogel material, these lenses we are making only from silicone hydrogel material. Why is it good? Oxygen, water retention, and material rigidity. The semi-scleral soft K indications: poor tolerance to RGPs, recurrent RGP or other soft spatial lenses erosion and decision, prevention of corneal demolding, corneal shortly after cross-linking procedure, or cornea with stromal haze. We can see here the very nice fluorescent pattern that we pictured with these lenses. Of course, this is big molecule fluorescein, and we can see that the lens is just riding over like a scleral, a GP scleral lens, of course, with a minimal apical touch. So the lens is over the cornea. There is no really touch, only maybe in one page just to ride on. So the lens is a very nice vaulting the cornea. We can see here the nice sitting of the lens over the cornea. There is no any problem with blood vessels, so we get a very nice vision and comfort with this lens. This is the sketch of the lens. We have 3 holes for the toric design, just to show where is the lens is stabilized, and 4 holes for the normal. The lens has 17 millimeter diameter, and we have aspheric front surface for high order aberration. The thickness of the lens is about 0.5, 0.6 millimeter, the fenestration and diameter. We can see here some pictures that we have done with this lens. The benefits of the silicone hydrogel semi-scleral soft A, limbal vaulting zone, no mechanical irritation here in this area. A scleral landing zone, the lens support multi-curve periphery. So we have 2 base curve or 2 curves for the scleral support, lens support. We have medium and flat, and we can use the big molecule fluorescein in order to evaluate the fitting of this lens. We are using the definitive material, and we found out that with this material, the flux of oxygen is 5 times greater than in hydrogel. Also, Gonzalez from Portugal did this research. So in these lenses made of silicone hydrogel, we get 5 times more flux, oxygen flux than in hydrogel. There is, because of the fenestration of this positive fluid ventilation, the fenestration prevents lens adhesion, improved limbal oxygenation, and tear mixing, and of course centration. So we get from this fenestration a very, very good behavior the lens on the okay. The fitting recommendation, it is a table. I'm not intend to go into this, but when you have this, you choose this, and so and so and so. So this is a very easy system to evaluate the first choice lens. The trial set is regular and steep periphery, okay, with 5 base curve for the regular. Every lens is engraved, so a moment we can put it on the eye, we can see immediately what lens we have. The power of the lens is on the label, but it is changeable from lens to lens. And we have the steep lens. We have only 4 lenses. Toric, we have 3 fenestration holes, and for the spheric we have 4 fenestrations also. It is very easy to differ each other. And of course, here the third hole signs the stabilization of the toric lens. As I said before, Dr. Severinsky did also research for this lens in Hadassah, and he did it for 36 eyes, 22 patients. The success criteria was wearing time bigger than 10 hours per day. This was the most important issue. Of course, it is related to best correction and physiological response monitoring after 3 and 6 months. We can see here that in most of the cases there is a nice improvement between the best correction visual acuity without the contact lens and with the contact lens. So if it was, for example, 0.4, it becomes 0.6. If it was 0.4 here in this case, it become 0.8. In this case, it was 0.6 become 1. So there's a nice advantage of vision with these lenses. %72% of the eyes meet the success criteria of using this lens for more than 10 hours. The vision stability was greater than 8, and overall comfort of grade was bigger than 7 in 91% of the people. So we can call it a success lens. According safety, there was no any staining, redness, and papillarity conjunctivity or corneal new vessels of blood on the cornea, according to night and nephron grading scale. So this was the reference of evaluate the safety of using these lenses. After 3 months, we have 36 eyes come to evaluate, and after 6 months follow up only 20 eyes, but maybe those people still staying with these lenses. As I said before, with these lenses, we can also challenge residual astigmatism. And so front astigmatism can added to these lenses with prism balance stabilization. If, for example, the original lens was 7.3 minus 8, the visual acuity was 618. Adding the astigmatism improved dramatically the vision. Of course, no talking about contact lenses without daily cleaning, without general lens care. This is the Everclean, which is very good for scleral lenses, GP and soft, and for all soft lenses. We are using this system in our place, but in any other place you have your own systems. So when we talk about fitting of contact lenses, the fitting of contact lenses must be includes how to take care of the lenses. So thanks to Professor Patrick Howland and Randy Kojima with part of information about this presentation. Thank you very much, and maybe see you next year in Mido. Okay, thank you very much. Of course, if you need to ask question, you want to ask question, you need edit the information. Of course, you may call me or send me a mail. I'm for you. Thank you very, very, very much.